This is question 15 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of vectors. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. This is the first part of a two-part question. We've been given two vectors, A, B, and A, C, where A, B, and C are 3 points. And we've been asked to prove that A, B, and C lie on a straight line. Vector AB is equal to 3A plus 4B. And vector AC is equal to 15A plus 20B. A vector is a quantity that has both magnitude and direction. They are drawn as arrows, where the length represents the magnitude and the tip represents its direction. The vector AB represents a directed line segment that starts at point A and ends at point B. The components describe a path from A to B, using vectors A and B, with vector AB the resultant of that path. 3 points, A, B, and C, are collinear if the displacement vectors A, B, and AC are parallel. In other words, the direction from A to B and from A to C lie along the same line. To demonstrate collinearity, 2 conditions must be met: that one vector is a scalar multiple of the other, and that both vectors share a common point. Answering this question is a 2-step process. First, we need to find the scalar multiple of the A components of each vector, and the scalar multiple of the B components of each vector, before demonstrating that one vector is a scalar multiple of the other. We've been given 2 vectors: the vector AB equal to 3A plus 4B, and AC equal to 15A plus 20B. If 2 vectors are parallel, the ratio of their corresponding components must be the same. Comparing the A components, the A component of AB is 3, and the A component of AC is 15. The ratio of their A components is therefore 15 divided by 3, which is equal to 5. Comparing the B components, the B component of AB is 4, and the B component of AC is 20. The scalar ratio of their B components is therefore 20 divided by 4, which is equal to 5. The ratio of the components of both vectors is 5, telling us that vector AC is a scalar multiple of vector AB, 5 times larger, in fact. So mathematically, that means vector AB is equal to 5 multiplied by vector AC. Both vectors also share a common point. Starting at A moves us along a line towards B, which then moves us along the same line to C, indicating that all 3 points lie on a straight line. For more explanation and examples of vectors, search our channel for vectors. This is the second part of a 2-part question. We've been given 2 different vectors, DE and EF, where D, E, and F are also 3 points on a straight line. And we've been asked to find the ratio of the length of DF to the length of DE. DE is equal to 3E plus 6F, and EF is equal to minus 10.5E minus 21F. Answering this question is a 4-step process. First, we need to find the vector DF using the vectors given to us. Then, by comparing the E components and F components of each vector, find and interpret their ratio before expressing their length as a ratio and simplifying. We've been given vector DE and vector EF, and told that the points D, E, and F are collinear. The vector DF is the sum of both vectors. In other words, vector DF is equal to the sum of vector DE and EF, where DE is equal to 3E plus 6F and EF is equal to minus 10.5E minus 21F. So 3E plus 6F plus minus 10.5E minus 21F which is equal to minus 7.5e minus 15f. The vector dE is equal to 3e plus 6f, and df is equal to minus 7.5e minus 15f. Comparing the e components, the e component of dE is minus 7.5, and the e component of df is 3. The ratio of the e components is therefore minus 7.5 divided by 3, which is equal to minus 2.5. Comparing the f components, the f component of dE is minus 15, and the f component of df is 6. The ratio of the f components is therefore minus 15 divided by 6, which is also equal to minus 2.5. The ratio of both components is minus 2.5, where the minus sign is largely symbolic in this context, indicating that while collinear, one vector is pointing in the opposite direction to the other. Vector df is a scalar multiple of vector dE, and so df is therefore equal to minus 2.5 multiplied by dE. Magnitude allows us to ignore the minus sign, so the ratio of the length or magnitude of df to dE is therefore equal to 2.5 to 1, which we can simplify as 5 to 2. Answering this question successfully relies on our understanding of vector notation and components, the conditions for collinearity, scalar multiples and common points, and the rules for vector addition and ratio simplification. So the ratio of the lengths of vector df to dE, and the answer to this question is 5 to 2. Please follow us on Instagram, TikTok, and Threads for daily maths content.